Hello, my name is Beth Dixon, and this is a video series based on Vicki Borlaug's PowerPoint presentation on hypothesis testing on the mean. On the problems that we're looking at, X is normally distributed with the sigma or population standard deviation unknown. I wish to thank Mrs. Borlaug for allowing me to use her PowerPoint to make this set of videos. And this is part 4 on the series, and we are picking up with a last example, or at least I hope I get through the last examples on this part 4. Let's review again rather quickly the 5 steps that we use to do hypothesis testing. We set up the hypotheses, define the critical region, use the data to find the test statistics, make a conclusion based on the data and the test statistic, and write a sentence in terms of H1. We use the structure, whoops, I just blew right past that. One click too many. We use the structure defined by Mrs. Borlaug to help us do so because it will help you remember the 5 steps that we need, as well as to give you some kind of structure and make it easier to find all of your answers. So this is the structure we're going to use, and we are doing example number 2. A manufacturer of a certain model of car claims that the mean gas mileage is 29 miles per gallon for highway driving. A random sample of 22 cars of this model had a mean of 28.2 miles per gallon and a standard deviation of 1.6 miles per gallon all highway. Assume that the highway gas mileage is normally distributed. Using a 0.05 level of significance, test the claim that the mean gas mileage is not equal to 29 miles per gallon for highway driving. So from the problem, we have the X bar, or the sample mean, of 28.2, the standard deviation of 1.6, the sample size of 22, and we rewrote that there. We had a significance level of alpha equaling 0.05, and I'll rewrite the claim that the mean is not equal to 29 miles per gallon. So I have the relevant information listed. And I'm going to write down the structure for solving and doing a testing of the claim. I have my 5 boxes as defined and separated out. And the first of those boxes is to find my hypotheses, the null and alternate hypothesis. The claim states that the mean is not equal to 29 miles per gallon, so that will be the alternate hypothesis, mu not equal to 29 miles per gallon, since that is what we're trying to prove from Ms. Borlaug's point of view, or since that does not contain the equal, if you're using a different teacher's point of view. The null must contain the equal, and so it will be the mu is equal to 29 miles per gallon. And Ms. Borlaug went on to talk about the fact that this is a two-tailed test, which I will do now. And we know that this is a two-tailed test since not equal to is a two-tailed test. Not equal to means that we're testing both higher and lower values than the claim. And our mean will be equal to 29 miles per gallon. I think she got her order mixed up in the clickings there. But since we're a two-tailed test, we will shade both left and right, and our significance level will have to be divided into half. Why is that? Well, we want a 0.05 significance level, but because there are two tails, we're not going to put the significance level in both tails. The total significance needs to be 0.05. So we will put half of the alpha risk in each tail. So that's alpha divided by 2, which is 0.025 in each tail. And our degrees of freedom is n minus 1. 22 minus 1 gives us 21. And looking up degrees of freedom of 21 and an alpha divided by 2 of 0.025 gives us a critical value from our t-chart of 2.080. I'll get it said right. Sorry about that. Well, that would be a positive 2.080 on the right-hand side, but would be a negative 2.080 on the left-hand side. And since we have two tails, we'll have two shaded regions and two critical values. Now notice what that does. That gives us three total regions, two that are shaded and one that is not. So that gives us two lines in the sand, three regions. We have two shaded regions, which will be the reject regions, and the one in the center, which would be the do not reject regions. Let me say that. I probably should have said that slower. We have a reject HO in the shaded region to the left tail. We have a reject HO, which is a shaded region in the right tail. But between those, we have a do not reject HO region, which is between the two tails. It is now time to do the test statistic. The formula is the same, x bar minus the mean sub 0 divided by s divided by the square root of n. X bar is our sample mean, which is 28.2, minus the mean of our null, which is 29, divided by the standard deviation of 1.6, divided by the square root of 22. Remember that when you place this in the calculator, to place parentheses around both the top and the bottom of your fractions. That will give you a negative 2.345. Remember that we're taking this out 3 decimal places because our critical value are 3 decimal places. And when we graph negative 2.345, does it fall below, between, or above the negative 2.080 or the positive 2.080? And you'll notice that it falls below the negative 2.8080, just slightly below. And since it falls below, that is in the shaded region. And since it's in the shaded region, it's in the reject HO region. That means it's unusual. It would be unusual to get a set of 22 cars with a sample mean of 28.2 miles per gallon if HO, the mean of 29 miles per gallon, was true. And since that is unusual, we will reject HO. So we're rejecting HO. So our sentence would be, using a 0.05 level of significance, there is enough evidence, or there is evidence to say the mean highway mileage is not equal to 29 miles per gallon. And this down here is just a restatement of the claim. But there is evidence to say, because we rejected HO. Here is a class question for you to try. If this is a quiz for you, remember that you do not receive credit unless you show all of your work. Here are some of the answers. Remember that, again, that you need to write your sentence and do all of the steps to receive full credit. As always, if you're a Walter State student and need additional help, you are welcome to come by and see me in the Math and Behavioral Social Science building in room 222. Thank you.